Let us now work on input, because we're going to need that in order to make the character move. So better set it up first. And for input listening, we're not going to use the input callback directly. So in Godot, you have an input method, a virtual one that you can override to get every input event. But when you want to continuously listen to the input, like when moving the character with the arrow keys, you want to listen to that on every frame, you'll want to instead use the input singleton. So once you have something like process or physics process, one of the virtual methods that GDScript provides you with, Godot provides you with, that gets called on every tick, on every frame, inside of that method, or anywhere really, you can use the input class that is globally available, so it's a singleton, and you can call any of its, for example, isActionPressed method. You then pass that method the name of an input action. These are the input actions that we define in our project settings in the input map. And it will return true or false. True if the action is pressed on that frame, so either the A or the left key, or false if the action is not pressed. But we are going to encapsulate these calls in a function and in a static function. So let's delete that for now. We're going to create a static function. We'll call it getRawInput. This is going to take all the input we need to change the state of our character or to make it move. For now, it doesn't need any parameter, and it's going to return a dictionary with some information about the keys that the player pressed or the input that's being active. Then we will create another function, another static function as well, that we'll call decode the input. And this one is going to take our input dictionary, or let's call it just input here, and it will convert the input to events. So it's going to return some event, something like events.stop, for example. Static functions are functions that cannot access the state of the object. In any or either of our static functions here, getRawInput, for example, we cannot access the state variable. This should give us an error. In this case, unfortunately, it does not, but this will give you an error at runtime if you try to access any of the variables in this player script. The point of using them is to safeguard you against modifying the state of the objects, modifying one of these properties or any properties on the object. Static functions that are going to make calculations and return a result. And in order to make a function static, you use the static keyword before the function one. You use these to create libraries of reusable functions. But in our case, in this script, the getRawInput and decodeRawInput functions are really safeguarded, are protected against modifying the character. And doing that prevents you from producing too many bugs. In the final version of the course, you have a script called utils.gd that any script can use, can access to get the input direction. So we are going to create that now. In the script editor, you can go to File, New Script to create a new GDScript file anytime. And we're going to store it in the helpers folder, and we'll call it utils.gd. The code we are going to put in this new script, you could put it in the player.gd script. The point is to create functions that will be globally accessible in the project and to show you how to create a singleton though. Let's create that. We're going to remove everything, but we're going to create a static function and we'll call it getInputDirection. And this one is going to return a vector2, the direction that is represented by the keys the player just pressed. We're going to use a little trick here. The input direction, you will often calculate it in physics process or something like that with calls to the input singleton. To make it so, we can port this code to, for example, one of the input callbacks, input like that, or unhandled input, which you want to use for player movement, etc., for things that are not UI, for gameplay code in general. We can do this little trick. In the argument of the function, we're going to create a variable called event, and we will assign the input singleton to it. So now we can type event dot, for example, isActionPressed, and this will correspond to input dot isActionPressed, making it so it works exactly the same way as an unhandled input callback here, even though we're using the input singleton instead of an input event. We are going to do some calculations here with our input. We're going to type first check which keys are pressed by the player, or which input actions. For that, we can call the isActionPressed on the event variable here, on the input singleton, and we're going to check for move right. And we're going to duplicate the line and check for move left. So for now, this is going to give you an error because this is not a correct line of code. Plus, isActionPressed returns Boolean values. Now, we can wrap this in parentheses, and we can use the built-in float function in GDScript to convert that Boolean value, true or false, to a floating point number, 1.0 or 0. And once we have that, we can do subtractions. So we can subtract the result of the float conversion for checking if the move left event is pressed. The move left input action is pressed. This is what it's going to give us. If the player is pressing the right arrow key, this first call, isActionPressed check, is going to give us a value of 1.0. And if the player is not pressing the left arrow key at the same time, it's going to be -0 here, giving you 1.0 on the vector's x-axis. And if you just press the left key, you will get -1.0. We can do something similar on the y-axis. We're going to check if down is pressed, and we're going to subtract move up, because moving up is -1 and moving down on the y-axis is +1. The y-axis points down by default in a 2D game. You have to remove the last comma as well. And we have one last thing to do. We need to normalize this vector, because if we are going to the right and down, the vector will have a length of 1 on the x-axis and the length of 1 on the y-axis, meaning it will have a total length of square root of 2. And by normalizing the vector, we make sure that our vector's length is always 1.0. Otherwise, when we multiply it with our player's speed, it would walk faster and diagonal than on the x or the y-axis only. For that, there is a normalized method that you can call on vector2. We're going to save this script, and we're going to register it as a singleton globally. By the way, I will make it so the normalized call is at the end of the last parent here, and I'll go to project settings. Then you want to go to autoload, this tab, which allows you to register one GDScript file that needs to extend a node type, so it needs to be a node, and it will be globally accessible in your project. It will be added at runtime to the scene tree, even though it will not be visible directly in your scene tree. So first you want to input the path to your utils.gd. We're going to have that here. Then you want to name the node. We're going to use a capital U and add it to the project. When it's enabled, you can access it from any script as utils dot, and then you can call get input direction. Let's now work on our player script. Let's get back to it and work on the get raw input static method. In this one, we're going to first store two elements in our dictionary. We're going to store the direction of the character, and for that we will call utils.get input direction, and it will return a vector2. It will return the character's direction. Then we want to check if the player is running or not. And for that, we're going to check the input singleton and check if the action run is pressed. And that's it. That's all the information we'll need for now. Later, when we add the jump, or as you add more mechanics, you will do more checks in there and add more information to this dictionary. Now, we need to decode that input to convert it into events that our state machine will use to transition from, for example, idle to walking. So we'll create an event variable at the top of this one, and by default, it's going to be events.invalid, meaning once we try to change the state based on that, it's not going to do anything. Then this decard raw input will get some inputs. I should call it input dict maybe, but in the final project it's called input, so for consistency's sake we'll leave it at that. And this input is going to be the dictionary returned by get raw input. So we can assume that input has direction and is running as keys here. If we don't have any direction, we're going to stop the character. So input.direction. Note that as this is a dictionary, you can write it this way as well. You can write with strings input direction this way. And the notation here in get raw input is the same. Instead of using the equal sign, you can use colon and a string before the colon. This is the typical Python-like notation, and GDScript also supports Lua-like notation with the key as any variable name. You just write the key that you want equals followed by the value. And then you can access these keys using the dot notation. Input.direction is a vect2. We're going to set event to events.stop. If there's no move direction, it means the character is supposed to stop. Then, if the character is running and there's an input direction, let's use is running here, event is going to be set to events.run. Otherwise, so we check if there is no input direction. If we get to that elif block here, it means that there is an input direction, so the player wants the player character to move. Else, if the player doesn't want the character to run, we're going to assign events.walk to our event here. And we're going to return this event variable. And then the processing of that event, changing the state, will happen in another place in our code. But with that, we can listen to the character's input and we will be able to make it move.